Hi friends, so here now we are going to solve a numerical again which is based on the inverse Laplace transform of the log function, but this time it is not the simple log function. Here we are going to use the property two times and get the answer of that inverse Laplace transform of that log function. So let's see. So here we have to find out the inverse Laplace transform of s into log of s plus 1 upon s minus 1. Now guys, since here we have the log function, we can't find out the inverse Laplace transform of log function directly by using the standard formulae. So here we have to use the property. Now what is the property? So this is what the property is, which I've already covered in previous 4 problems, and I'm sure that you must have seen my previous 4 problems. So it is in continuation of those 4 problems. So I'll be using this property, that is Laplace inverse of phi of s is negative 1 by t Laplace inverse of phi dash of s. So this property says that if I want to find out the inverse Laplace transform of phi of s, then find out the derivative of that, which is phi dash of s, and make sure that the inverse Laplace transform of that derivative is possible, because then only this property makes sense. So guys, I'm gonna use this property where phi of s is my given function, and let's see what we get in the answer. So here I'll say so guys, by using the property we will get negative 1 upon t Laplace inverse of, now here it's derivative of this function. Now guys, the derivative we cannot find out directly, or we can find it out, but I'll not prefer to find out it directly, because this log function is again having numerator and denominator and it is looking quite complex. So what I'll do is I'll simplify this log function by using the logarithmic property with log a upon b, and log a upon b, you all know that it is log a minus log b, and to that log a minus log b I'll multiply with s. So here we will get now let's find out the derivative of this function. So here I'll write down negative 1 upon t and L inverse as it is. So if you see this function s into log of s plus 1, here to find out the derivative of this, we can use the u into v rule, or the product rule of derivative. So according to it, this first function s as it is, we'll find out derivative of log, which is 1 upon s plus 1, then middle sign plus, then this term will remain as it is, that is log of s plus 1, and the derivative of this s is 1. So we got this answer. Then we have negative sign, so minus, and we'll write down the answer in the bracket, because due to the negative sign these signs are gonna change. Now u is as it is, that is s, derivative of this log term is 1 upon s minus 1, next middle sign plus, then log of s minus 1, and derivative of s is 1. So here we got the derivative of these two functions. Now let's find out the inverse Laplace transform of all these functions. So this is negative 1 by t. Now guys, if you'll see this function, first function, that is s upon s plus 1, then we cannot find out the inverse Laplace transform of this function directly, because we do not have any standard formula to get the inverse Laplace transform of this. So let's say if we would have 1 upon s plus 1, we would have said yes, it is e to the power minus t. Or if we would have s upon s square plus 1, then we would have said that it is by using the cos function, that is cos of t. But both things are not there. and that is why we cannot find out the inverse Laplace transform of this s upon s plus 1. And same thing is applicable to this s upon s minus 1. Now guys, the question is how to get the inverse Laplace transform of these two functions. So there are two ways. Either we'll do the adjustment, that is we'll add plus 1 and then we'll subtract 1 and we'll find out the inverse Laplace transform, or what we'll do is we will take LCM of these two functions, and by taking LCM we will get one more new function, and for that new function we'll find out the inverse Laplace transform. So this thing will do for first two or first and third function. Now what about the second and fourth function? Now second and fourth one is a log function, and guys, we know that for inverse Laplace transform log we do not have any standard formula. So it means for this log we have to apply this same property once again. So one more time I'm going to use the property for this log function. So let's rewrite these two terms together, because for this we can find out the inverse Laplace transform by doing simple adjustments. And let's write down these two functions separately, because for these two functions we have to apply the property, that is the differentiation of phi of s property once again. So here Laplace inverse of s upon s plus 1, this is negative s upon s minus 1. Here I'll close the bracket. Now this negative 1 by t is multiplying all the terms. So I'll write this negative 1 by t one more time. And now in the second bracket I'll say Laplace inverse of this remaining two function, that is log of s plus 1 minus and plus will become minus. Here I'll write down the sign, and log of s minus 1. Now here, as I said, that I'll be finding the LCM. So I'll do the cross multiplication and then I'll multiply the denominators. So here we'll get negative 1 upon t in the bracket, or obviously it is Laplace inverse. So s into s, that is s square, s into minus 1 negative s, this will become negative s into s, negative s square, and negative s, upon this into this will become s square minus 1. And this function as it is, which is minus 1 upon t, Laplace inverse of log of s plus 1 minus log of s minus 1. So guys, here I am purposely not applying the property. I'll be applying that property on the fresh page. Now let's simplify this. So we can cancel this s square with negative s square, and we will get minus 2s. So out of that I can take minus 2 outside. So here we will get minus 2 into minus 1, that is 2 by t. So it is equal to 2 upon t, Laplace inverse of s upon s square minus 1. So guys, here only s will remain. I have taken minus 2 outside. Similarly here, minus 1 by t as it is. And now to find out the inverse Laplace transform of this log function, I am going to use this property once again. So as per the property, the answer is negative 1 by t into Laplace inverse of derivative of this function of s. Now guys, this time this will be my new function of s, and if I apply this property, then my answer will be minus 1 by t into Laplace inverse of derivative of this. So here I'll say it is again minus 1 by t Laplace inverse of derivative of this. So derivative of these two functions I'll write down directly. So it is 1 upon s plus 1 minus 1 upon s minus 1. Now let's solve further. So here I'll get 2 by t as it is, and we know that inverse Laplace transform of this function is hyperbolic cos of t. So guys, I'm sure that you have revised all the formulae of inverse Laplace transform. Next, minus 1 by t into minus 1 by t will become positive 1 upon t square, and the inverse Laplace transform of this function is e to the power minus t minus e to the power positive t for second function. And guys, if you see, then here I got a function of t. So here we have found out the inverse Laplace transform of this given function by applying the differentiation of phi of s property two times. So I'm sure that you understood the way I've explained it, and I'm sure that you're gonna get good marks in examination by applying this method. So thank you very much for watching the videos. Keep watching the videos to understand the engineering mathematics in detail. Thank you.